Now, good morning, students. We are already discussing the properties of bulk matter. In that, our first chapter, that is the elasticity, that is a property of the solids mainly, have been discussed. Our today's discussion starts with the pressure in fluids. Fluids. First of all, what is a fluid? Let us first discuss what is the meaning of a fluid. Fluid means the substance which has a tendency to flow. Fluid is the substance which has a tendency to flow. That type of the substance is known as a fluid. And under this category of the fluid, mainly the liquids and gases. Under this category, the liquids and gases are included. Fluids means the liquids as well as the gases, but I just tell you, in our syllabus mainly we shall concern with the liquid. Obviously, the gases are also there under this fluid, but in our syllabus we will consider mainly the liquids. Now, we are first going to, now onwards, whichever topics will be coming. In those topics, we shall discuss mainly regarding the property of the fluids. Like, first we are starting with pressure in fluids, then the viscosity, okay, then Bernoulli's theorem that will concern with the flow of fluids, then the surface tension. Up to surface tension, we will be discussing the properties of fluid. This is just I am giving you the introduction to all the things what we are going to do. So, we have to discuss the different aspects of fluids. So, let us start with the pressure. So, in the discussion of the pressure, let us first have a discussion regarding the thrust. Let us discuss regarding the thrust. What is the thrust? Thrust is the force exerted by a fluid on the surface of the solid. You can write the thrust is the force exerted by the fluid on the surface of the solid, with which it is in contact. All right. That means, suppose if a fluid is in contact here, let us say a fluid is in contact with, like this, a solid. This is a container with which it is in contact. On that, whatever amount of the force it is exerting on the base, suppose you can say, with which it is in contact, that is called the thrust. And the pressure P is equal to the thrust by area. Effective area, the area on which the thrust is acting. Obviously, you can understand its unit should be Newton per meter square. This is the pressure exerted. Okay, now you can say that suppose it is a still liquid, then in which direction the thrust or the force, thrust is a type of force, thrust or the force will be acting. Just like here it is, thrust is, if I say F by A. So how the thrust will be acting in a still liquid? I am talking about the still liquid. We are not considering the flow of the liquid at this moment. We should discuss the flow. That will be the fluid dynamics, but it is the fluid statics, hydrostatics, fluid statics, in which, let us say, suppose this is, look at this, this is a liquid surface. Suppose a force that is acting on it here, the force is acting on it, F vector, which is forming an angle theta. Suppose I say the force is acting on this surface obliquely, or force exerted by this obliquely. You know, obliquely, a term oblique. Oblique का मतलब होता है in an inclined way. The force is acting, or the thrust is acting in an inclined way. Obviously, it should have the two components. One should be F cos theta, and the other should be F sin theta. If force is treated as a vector, definitely it will have the two components. What are the components? The components are like this. One is the F vector, that is F vector is resolved into the two components. One is F cos theta, another is F sin theta. Now I can write here for still liquid. If the liquid is still, then what will happen? Obviously, F cos theta must be equal to 0. F cos theta is equal to 0 means there is no, you can say, movement. It's a still liquid, so no movement on the water surface. It is a still liquid. For a still liquid, F cos theta equal to 0. As F is not equal to 0, so cos theta must be 0, so theta must be 90 degree. Look, very simple thing. F cannot be equal to 0, cos theta must be equal to 0. Right? So cos theta, I write here, so cos theta should be 0, so theta must be 90 degree. That means the force will be acting perpendicularly. Normally it is acting. The force must be acting normally. So mind this, whenever a still liquid will be placed in a beaker or any container, okay, it will always apply the thrust perpendicularly. That's why I am taking thrust perpendicular direction like this normally. And here theta will be 90 degree and the area will be taken as the area of the base. I hope all of you have got this point. Alright, this is regarding the thrust. I have given you thrust and pressure. I have given you the introduction to this thrust and the pressure. Okay, thrust and the pressure, all these things I have given you the introduction. Right. Now we have to discuss a very important discussion, that is the pressure exerted by a liquid column. Let us discuss this. The pressure that is exerted by a liquid column. Okay. Look at this. Suppose this is the liquid. It's there. It's a still liquid. Okay. What I do, I consider, try to follow me. I consider here an imaginary cylinder. Let us consider an imaginary cylinder. There is no such cylinder existing. We are considering here an imaginary cylinder. If it is an imaginary cylinder, right, in which the liquid is filled up, let us say that capital A is area of cross section of cylinder, and H is the height. It is the height of the cylinder. I hope you are agreed. Height of the cylinder, that means what is this? This is the height. Let us consider this flat surface above is P, this flat surface below is Q. And this is the P, the upper flat surface. Q is the lower flat surface. Each have the cross-sectional area capital A, very clear. H is the height of the cylinder. Then what will happen? Now see, if I ask you what are the different forces acting on this imaginary cylinder? This imaginary cylinder is containing the liquid. Then, if I ask you, what are the different forces acting on this imaginary cylinder? You will say, one force will act like this, that is F1 by the liquid upper side. Another is this is mg. mg is the weight of the liquid column. mg is the weight of the liquid column, and these two forces are in the downward direction. Definitely I will consider F2 in the upward direction. You will say why? Because the liquid is in equilibrium. So obviously net downward force and net upward force should be equal to each other. They should counterbalance each other. Then only it is possible. Here, what is mg? mg is the weight of the liquid column. That means F1 is a force acting on the upper flat surface. F2 is the force acting on the lower flat surface, like this. Then what will happen for the equilibrium of liquid in the cylinder? For the equilibrium of the liquid in the cylinder, what should happen? F1 plus mg should be F2. As I told you, net downward force should be equal to net upward force, which implies F2 minus F1 is equal to mg is equal to, mg means what? It is area into height is the volume into rho is the density into g. Or I can write F2 by A minus F1 by A should be equal to H rho g. Or we can say here P2 minus P1 should be H rho g. Look, this is the pressure. You can say it is the pressure difference between the upper flat surface and lower flat surface. Okay, lower flat surface minus upper flat surface, like this. So this is the pressure difference I am getting. Okay, this we are getting. Now I am coming to some important cases of it in the next lecture.